Okay, good evening, Bao to students. Tonight I'm going to go over our digestive system review from food to waste. This is usually one of my favorite ones to talk about because it involves eating. I usually have like a snack, like a cookie or something like that when I talk about this, but I actually don't have any cookies right now. I ate them all already. So I'll just kind of talk through the process of how that cookie would have gone from my mouth, gone through my body. All the important stuff gets, absorbed by my body, and then how I would release the waste at the very end. So when we talk about food, it always starts in the head. So the process or the step of gastric activity that we are on is the cephalic phase. So when you are thinking about food, when you're feeling hungry, if you've ever noticed, like maybe you might not feel hungry, but that first time you start thinking, I haven't eaten in a while, or I feel hungry, then all of a sudden you really start to feel hungry. And that's all part of the brain essentially telling your body to start preparing for food digestion. So it's if you're already thinking about food, you're probably going to eat shortly. So your brain and your body goes through the process of preparing the body to receive food. So one of the things that starts happening is the salivary glands start secreting saliva more, the parotid, submandibular, sublingual glands, and then your stomach starts secreting gastrin. You might also feel especially if you have like an empty stomach, you might start feeling like the churning or the noise, and that's all just your body is kind of vibrating and kind of moving like it's ready to eat, but without any food, it tends to vibrate and make noise. When you actually have food in there, then it kind of muffles out the noise. You don't really hear it as much when you're actually eating. But again, first step is all in the head. You thinking about food is already preparing the body to receive food. Okay, so time to eat. So the first thing that happens is that cookie would go in your mouth. And through a combination of mechanical and chemical digestion, the body is going to start breaking down the cookie to the smallest levels, the carbs, the lipids, the proteins, etc. This is performed by things like mastication, where by chewing the cookie around or the food around, you can move it to different parts of your mouth that aren't necessarily being utilized. And you can kind of increase the surface area by spreading it out across the rest of the mouth. Your tongue also does this process of moving food around. So again, it doesn't just stay in one place. It helps you move it to like a cheek and back into your teeth and then back to another part of the mouth just to keep everything absorbing or breaking down. Again, this is the process where you start forming the bolus. Um, and then in the mouth, you'll also have a secretion of salivary amylase, which is found in your saliva. And this will account for about 3 to 5% of your carbohydrate digestion. The example I shared with our in-person class, if you think about like a cough drop, because I was taking a cough drop today, if you just leave it in your mouth, it does break down and slowly get, smaller. Part of the reason is that cough drops are primarily starches, sugars, a bunch of other kind of chemicals to help with like coughing or helping your body or your throat maintain like a mucus layer. But essentially, it's mostly just all a carb. It's fairly small. So it starts breaking down in your mouth really quickly. If I had that cookie, that Oreo cookie you see in front of you, if I just left it in my mouth and just kept sloshing it back and forth, in theory, the salivary amylase would completely break that down. It just might take a while. But on average, 3 to 5% of your carbs are broken down, um, digested, I'll use digested in the mouth itself via salivary amylase. Okay, so, like I said, you start forming the bolus in the mouth, but once you swallow it, it starts working its way through the esophagus as a bolus. Peristalsis, which is simulated by serotonin, will start then moving the bolus down into the stomach. This could take anywhere between 5 seconds to about, 30 seconds, depending on what you're eating. With food, you might sometimes not notice this, but next time you drink a really hot drink, um, if you're cold, or a really cold drink if you're hot, you can kind of feel the liquid working its way down your throat into the stomach. So just pay attention to that next time. You'll realize it doesn't take that long to get down there, especially a liquid. But 15 to 20 seconds, it'll be into your stomach. Um, the epiglottis in this case will also close, as you can kind of see up here, and that prevents the cookie from accidentally making its way through the trachea and into the lungs, which we don't want to happen. So once you get into the stomach, the bolus will then land in the stomach, and through mechanical movements and chemical secretions, the formation of the chyme will begin. For the purpose of this class, we'll just say that once the bolus hits the stomach, that is now chyme. In reality, that's where the bolus starts transitioning into chyme, but the bolus will start breaking down as soon as it hits the stomach. So we're gonna call this the chyme phase of the food or whatever we just ingested. Remember, very important that the stomach has three different muscle layers compared to the most of the other body where it has two. That oblique layer of the muscle that allows the stomach to kind of expand, contract, and then the oblique layer lets it kind of turn and churn around like rolling it around. Gastrin, which I mentioned, started secreting at the cephalic phase of gastric activity. So when we start thinking about it, gastrin will start simulating hydrochloric acid or HCl secretion, and pepsinogen, which is secreted down here by the chief cells, will interact with that hydrochloric acid to then activate and become pepsin. And pepsin will start protein digestion in the stomach. So carbs start digesting in the mouth, and they finish digesting in the small intestine, primarily the duodenum. For proteins, they'll start digestion in the stomach and then finish digesting in the duodenum. And just remember that this is now the gastric phase of gastric activity. So from you thinking about food until that food or that bolus hits your stomach, that is all the cephalic phase of gastric activity. Once the bolus hits the stomach and becomes the chyme, now it is the gastric phase of gastric activity. We can kind of see down here on the bottom left, I had a drawing, and I'll find that and send it out to everybody. But basically, I drew out the gastric pit and the gastric gland. So the gastric gland is what has all the different cells that secrete the different things that go into the stomach. So, for example, you've got your parietal cells. Those will secrete hydrochloric acid and intrinsic factor. The chief cells, those secrete pepsinogen. The enteroendothelium, I can't read that. Forgot what those were. Give me a second. I just looked this up too because I couldn't read it to begin with. The enteroendocrine cells. Oh my God, that's a terrible spelling. So I apologize for that. The enteroendocrine cells, or the G cells, I should have just said G cells, those secrete gastrin, which again, the secretion of gastrin triggers the secretion of hydrochloric acid, which then helps the pepsinogen, which is secreted by the chief cells, to become gastrin. And this upper layer, you've got the goblet cells. That is like the topmost cell of the stomach, and that secretes mucus to kind of protect the cells in the stomach. And then you have these mucus neck or regenerative cells. And these essentially, as you lose goblet cells, these cells will then replace the lost goblet cells. So it's kind of like, think of like your skin, lose the top layer of your skin, other cells build up on top of it. Same thing with the regenerative cells. Okay, so now that your food is sitting in the stomach for 1 to 4 hours, the bolus is fully that bolus is now fully chyme. Like I said, we're calling the bolus chyme when it hits the stomach, but once it gets to the small intestine, it is fully chyme. This starts the intestinal phase of gastric activity. So you have a couple things that get secreted into the duodenum that help kind of help finish that digestion portion and then also help with absorption. So the first thing that gets secreted is and these aren't in order, but you have CCK. This chemical will then trigger the liver to make bile. It triggers the gallbladder to release the bile into the duodenum, and it triggers the pancreas to start releasing its enzymes to start digestion the um, of the chyme that's in there. Secretin is also secreted, and this helps neutralize stomach acid. So remember, the stomach is very acidic, and the small intestine is very basic. So you don't want to just have stomach acid damaging the duodenum, the jejunum, the small intestine. So secretin helps with neutralizing stomach acid via things like bicarbonate. And then you also have GIP, oh, which stimulates insulin secretion. So even though you have not started absorbing anything yet, the GIP will basically prep your body to let it know you just ate. I'm gonna have a spike in blood sugar. So let's start getting insulin secreted into the body now so that when you have that spike in blood sugar, it's not as big, and the body can then start storing that sugar into the cells if it needs it. So again, the body's already preparing for you to absorb those nutrients without you even starting to absorb the nutrients. Okay, so in the small intestine, absorption, this is where it happens in the body. The duodenum, like I mentioned before, will finish digestion. That's through the secretions of the pancreas. Um, and then the jejunum, which is the longest part of the small intestine, that will be where absorption or most absorption occurs. And then in the ileum, once you get here to the very end, B12 will be absorbed as long as there's enough intrinsic factor, which again is secreted, like I mentioned before, by the parietal cells. The pancreas, like remember, it does serve two functions. It has an endocrine function, which we spoke about when we got to the endocrine unit, and it also has the exocrine function. Primarily, it secretes, for this class, we'll talk about the things it secretes. We secrete pancreatic amylase. Remember, we have salivary amylase in the mouth, and then we also have pancreatic amylase um, in the small intestine. It'll secrete lipase, which helps it break down fats and lipids. And it'll secrete trypsin and chymotrypsin, which are your peptidases, which help you break down proteins. So, two chemicals, or two enzymes, I should say, help you break down sugars or starch. That's pancreatic amylase and salivary amylase. One uh, enzyme will help you break down fats or lipids. That's the lipase. And then we have three enzymes that we talk about: pepsin, trypsin, and chymotrypsin that help you break down proteins. And remember that trypsin and chymotrypsin are secreted by the pancreas, whereas pepsin is created in the stomach because the stomach secretes pepsinogen. So remember, pepsinogen is the secretion. Pepsin is the active form when you have hydrochloric acid. And then we also have peristalsis and segmentation happening in the small intestine. So similar to the esophagus, they have peristalsis going on, just smooth muscle moving the food along. Segmentation is more of a process where instead of just the way I kind of showed it here, I tried to show it, was that if I had eaten a broccoli yesterday and a cookie today, in the small intestine, I'm not going to have just the broccoli in front and then the cookie following behind it. The Small intestine will segment it to kind of break it up into tiny chunks. So instead of having like one piece of my jejunum absorbing or breaking down or absorbing only the broccoli, and then another piece absorbing only the cookie, it kind of mixes it all together. So I have a good um, dispersal of my cookie and my broccoli throughout my entire small intestine so that it can just absorb everything and break it all down evenly. Um, Probably the best way I can describe it. Just know that, just because you eat the cookie, or you eat the broccoli first, doesn't mean you're going to poop out the broccoli first. It really just depends on how the small intestine decides to segment things around so that it's getting an equal amount of absorption and digestion going on. Okay, so we did cover this in class today, but we had a lot of different terminology. Definitely study this for your notes. But in general, the easiest way to kind of think about it is we want to know how are things absorbed from the jejunum into the cells, and then from the cells into the bloodstream. So carbs, remember that we use secondary active transport with sodium to be absorbed into the cell. And then it'll use facilitated diffusion to get that carb or that sugar into the blood capillaries. Proteins also use secondary active transport with sodium to get into the cells, but the difference is proteins then use active transport to get into the blood capillaries. And then the only one that's really different is lipids or fats. So fats get absorbed via simple diffusion. Remember that we have the bile salts and lecithin emulsification. So it creates this essentially pocket of stuff around the fat or the lipids, and that allows it to kind of just diffuse into the cells because our cells also have that phospholipid bilayer, so the outer membrane of the cells. And then it gets secreted, or then it moves, or I'll say it gets transported into not the blood capillaries, but into the lacteals we talked about in the last unit. And it does that via exocytosis. And it secretes or goes out into the lacteals as a chylomicron, which we talked about in class today. Okay, so now I'm kind of made my cookies made it all the way through to the ileocecal area, ileocecal sphincter. So now my chyme going from the small intestine into the large intestine, that now becomes feces. So that is your poop. In the colon or the large intestine, um, this is where you start absorbing the water, the electrolytes, the bile salts you might have used earlier. Vitamin K is also produced by bacteria in the appendix and then gets secreted into the large intestine, then gets absorbed into the body. Um, you probably have heard of things like seen things recently where they've mentioned like, oh, hey, did you know your large intestine has poop and fecal matter and how bad that is for you? It's that stuff's hopefully by now you're realizing that stuff's garbage. The large intestine is designed to hold poop and fecal matter for long periods of time, depending on how often you use the bathroom. And it's held in there so that we got what we really needed to survive here in the small intestine. We got our proteins, we got our lipids, we got our carbs. That all absorption happens first. Once you get into the colon, then we can still absorb things, just the other stuff that we need, the water, electrolytes, bile salts, etc. Um, it needs to stay in the large intestine that long so that you can absorb everything as best you can before you excrete it and you poop it out. Imagine having diarrhea. Diarrhea is not good for you because it dehydrates you. It dehydrates you because you are not allowing these feces that have water in them to stay in the large intestine long enough to get that water absorbed. So all the water you're drinking, yeah, you're going to absorb some of it, but if you have diarrhea, you're going to lose a majority of the water that should be in the feces, staying in the large intestine for long periods of time. So if you ever hear things about, you need to flush out your large intestine because it's bad for you, no, you don't. It's normal. The body's been doing this for centuries before we had modern medicine. It's gonna be okay. Don't buy any of that stuff. So I was explaining this to the class. So you have what's called mass movements. Um, it's not necessarily like scientific, where the way I explained it was, if I've got feces in the ascending colon and the transverse colon and the descending colon and the sigmoid colon, and then going out towards the rectum. If I poop and I lose the fecal matter between my sigmoid colon and the rectum, then, the stuff that's in my descending colon goes into the sigmoid, and the stuff in the transverse goes into the descending, and the stuff in the ascending colon goes to the transverse colon. It does shift out that way. But it's not like constantly moving that way, if that makes sense. So it'll just move fecal matter in large chunks from, the ascending colon up to the transverse, down to the descending to the sigmoid, until you eventually reach the internal sphincter where it decides when it's held out too long. Um, Things that help you with mass movements, moving, walking around, making sure that your body is able to kind of use and burn some of the energy, but also just the movement of the motion of the body helps these things kind of move along. Obviously, eating, if you can eat, think about it this way: you start shoving stuff into the large intestine, it's got to start pushing stuff out. Um, but again, you on average about 1 to 3 times per day for mass movements. They say three is a healthy amount. Um, Everyone's situation is different. I think I use the bathroom maybe once or twice where I actually, do number two, if you will. But, on average, 1 to 3 times per day is healthy. You shouldn't be holding it out. It shouldn't take you that long to defecate once. If you're in that situation, I just, go talk to your doctor, make sure everything's okay. Other things that can affect this, if you remember, things like stress, things like what things you consume could create things like constipation where you can't use the bathroom. So there's all different things. But in general, 1 to 3 time movements per day. Know that defecation is controlled by the internal and external sphincters. So the internal sphincter is voluntary, the external sphincter is voluntary. So once the internal sphincter signals it's open, you get a message up to the brain basically saying, hey, go find a place to use the bathroom because, the internal sphincter is already open. It's not holding that back anymore. And at the very end, just like anything else, waste is eventually removed from the body through the anus, and then move on and go on with your day. So in summary, we kind of covered the three phases of gastric activity. You have the cephalic phase, which is where you think about food until the bolus hits the stomach to become chyme. You have the gastric phase, which is just in the stomach itself, the part of mechanical and chemical digestion and the ability to break that bolus into chyme, essentially. And then the intestinal phase, which is part of the small intestine and large intestine until you reach the end of the road at the anus. We also talked about differences in chemical and mechanical digestion. So that includes things like mastication. We talked about some of the different enzymes that are involved, where they're involved. We talked about the movements in the GI tract via peristalsis, segmentation, but also mass movements. And again, we just kind of talked about how our food goes through the body and becomes feces. That is all I have for y'all. Good luck on your exam on Thursday. Remember to bring your laptop or iPad or tablet um, down to the lab. You're going to have lecture in lab on Thursday for the exam in the lab room. If you don't have any kind of laptop or whatever, it's fine. We do have some provided that we can provide to you that the school owns. Other than that, reach out if you have any questions. I'll put the secret question or the keyword in the announcement. Have a good night.